In this video, we're going to use the rational zero theorem to find the rational zeros. It says use the rational zero theorem to find a rational zero of the function. So to use the rational zeros test, what we do is we take a p-value, which would be this ending term, the coefficient of that, and the coefficient of the beginning term, which we're going to call our q value. And we write out all the factors of p. So we're going to write out that this is plus and minus 1, plus and minus 2, plus and minus 5, and plus and minus 10. And then we'll write out all the factors of q, which would be plus and minus 1, plus and minus 3. And then we can write out all the factors then of p over q, because that's how the rational zeros test works. We take the p values, or the ending term, we divide it by the q values, and we write out all the possible scenarios. So that's plus and minus 1, plus and minus 2, plus and minus 5, plus and minus 10. That's just 1 divided by 1, 2 divided by 1, 5 divided by 1, and 10 divided by 1. Now I'm going to do the 1 divided by 3, 2 divided by 3, 5 divided by 3, and 10 divided by 3. Oop, comma in the wrong spot there. So we end up with plus and minus 1 third, and then plus and minus 1/5. No, not 1 third, then 2 thirds, then 5 thirds, lost track of where it was, and then 10 thirds. And then we're going to start checking these to find a rational zero. So the best way to check is to just start plugging in the entire function into the calculator and start plugging in random numbers. So if I plug in, or not random numbers, all these numbers. So negative 3, x to the third, minus 2, x squared, minus 5x, plus 10. Let's plug in negative 1 to start. We get 16, so negative 1 doesn't work. Let's plug in 1. And I'll just go straight down the list. One is a 0. So we found our rational zero here, and we're going to say that the rational zero is 1. Now we can continue to plug all these in and see what we get when we plug them all in. And maybe it's a good idea to do that. So let's just go through and continue plugging them in. So we'll start with, make sure there's no other ones. We'll go 2, store it as x. Doesn't work. Negative 2, store as x. Five stores x. None of these are working so far. Negative 5 stores x. Almost halfway through. 10 stored as x. Negative 10 stores x. And then we'll do 1/3. We're going to store that as x. And then we're going to grab that piece and we'll make that negative 1/3. And then we'll go 2/3. Nope. And then we'll take that and go negative 2/3. 5/3. Actually, we'll do negative 5/3 first. Nope. And now we'll grab that and we'll do positive 5/3. And finally, we'll do 10/3. And negative 10/3. And you can see none of these are working because we're not getting zeros. So, out of all these numbers, we only had one rational zero, and that was the number 1.